All right, so simplifying rational expressions. Rational expressions, reminder, has a root ratio. So these are fractions, and typically the fractions where we have our variable either in the numerator or the denominator, and this causes some issues. One of the things that you're asked to do often is cite the domain restrictions that are placed on a rational expression. So I got a little note here. There's the two times when you're going to be asked really commonly to come up with the restrictions are basically these are things you're not allowed to plug in. These are if x is our independent variable, or we might have more than just one independent variable, but whatever you could plug in that would make the denominator zero would be a problem. So we have to exclude those from the domain. And then it's kind of like just setting ground rules saying, okay, we all promise we're not going to plug in this case, what would make the denominator zero? Well, an easy way to do this is I'm going to take that expression on the bottom, the denominator, and I'm going to set it equal to zero. And then whatever value of v I come up with, I have to promise not to plug in that value of v. So I'm going to restrict it. I'm going to leave it out of the domain. So if I solve this, so again, I just took the bottom and I set it equal to zero. Whatever values make it equal zero, don't plug them in, please. So minus one, 2v equals -1, v equals -1/2. That would be a problem. So I am allowed to plug in any other value of x except I can't, or v, except I can't plug in v equals -1/2. This is a really common way to express that. Or another way to express this using interval notation is you could say I can plug in anything less than -1/2 and anything greater than -1/2. And in interval notation, you would say from -infinity to -1/2, I'm not going to plug in -1/2. So I'm going to use a parentheses there because in interval notation, this means not including. And when we have when we have infinity, we can never include infinity. We can never reach infinity. And so it's all anything in this interval is fine, or anything from -1/2 to infinity is fine. Again, not including. Let me finish that word. So it's pretty simple. You're looking for numbers that make the denominator zero. If you have a radical function, you're looking for numbers that would make the radicand, which is the thing underneath the radical. If it makes that negative, we have a problem, right? Because you can't take the square root of a negative. I know we can introduce imaginary, but typically when we're talking about functions over the real values, then we have to avoid values that make the radicand negative. Zero is okay. You could take the square root of zero, but you can't take the square root of a negative. So here we have another one. And when it's factored, I got this note here that I made. When it's factored, it's super easy. If I were to plug in 3, that would be a problem. So x could not equal 3. 3. And then what else can x not equal? X could not equal 2. Something that gets that idea across for me is fine. You might want to be formalized here. Also, if I promise I don't allow x to equal 2, if I make that promise, then x minus 2 over x minus 2 will always be 1. As long as I make the promise, I'm not going to set x equal to 2, then I can cancel these. That's 1. 1 times x plus 5 over x minus 3. So this will simplify to x plus 5 over x minus 3. In fact, the graph of the original function looks like that. It looks like this times 1, but we have to make sure we exclude the point on the graph where x equals 2, because this graph, y equals, this graph will have a point at x equals 2. I'm not sure what the y coordinate is. We could just plug in. It looks like it would be 2 plus 5 over 2 minus 3. So it looks like the y coordinate would be -7. So 2 comma -7. shows up on this graph, but I actually have to leave it out if I'm graphing this original function, because this original function, you're not allowed to plug in x equals 2 because it would make the bottom 0. And then we have some more down here. Simplify the expression. This one, simplify the expression. There's not a whole lot you can do. I notice each of my coefficients up here are multiples of 3, so I can reduce that, but they don't all have an x in it. So we can show this in a couple of ways. I can just say, oh, I'm going to reduce my 3. Common mistake students will make is they'll just do that and say, I'm done. But no, you're multiplying the top and bottom by 1/3. 1/3 on top and 1/3 on the bottom, and you need to distribute it. Okay, so this is just going to be x squared plus 2x minus 3. So I distributed a 1/3 to each of those, and I multiply the bottom by 1/3, and I just get x. So this I would consider simplified. There are sometimes when you want to go a little further with it. There might be reasons why you might want to. And I could actually take my x and divide it into each of these terms and express it as 3 unique terms. So this is going to be x squared over x becomes x. I guess I have to make sure that I exclude 0. X could not equal 0. That would be bad, right? So as you're working with problems that have fractions, these rational expressions, probably the first thing you should do is figure out what are values of x that I have to leave out. Now, let's work with it. So plus 2x over x is 2, and then minus 3 over x. So I could also express it like this. I'd be happy with either one. All right, hopefully that helps you.